Here we have the silver nanofiltration system. Basically, nanofiltration is very similar to RO, except we use this membrane that actually only takes out half of the mineral content of the water. Now, this typically gives you a much nicer tasting water if you're already on a relatively low mineral content. However, if you have a high TDS water, say 150 parts per million or over, rather look at RO. But if you're running something like Gauteng or Western Cape, well, specifically Cape Town municipal water, something like this really gives you an excellent tasting water. It's the one I prefer, and it's the one we'd normally recommend for people in either Gauteng or Cape Town and surrounds. Basically, what you get with the system is the unit itself. You get this standard tap, you get your half-inch supply connectors, you get a drain connection, your tank valve, your pressure protection valve, 5 meters of pipe spanner, your standard pre-filters, which is a particle filter, a granular carbon filter, and a carbon block to remove chlorine, and then you get the tank. Where you would want to use the system is only areas without too high of a bacteria load. Otherwise, upgrade to the bacteria filter set, or rather look at the gold nanofiltration system. This is probably one of our most popular systems on the market, because everyone who tastes the water just absolutely loves it. If you're looking to get an idea of it, go have if you're say in Gauteng, go have a look on the shelves for water with about 70 TDS, and that 70 TDS is the mineral content, and that'll give you sort of a ballpark idea of the kind of taste of water you would get from a system like this. Okay, so let's look at how the actual system works. Basically, first thing to keep in mind, there's two variants. There's this, which is the one without a pump, and then we'll show you the one with a pump in a little bit. And basically, if you have over 3 bar pressure, or are happy to run the system with a bit more wastewater, the standard unit without the pump is quite a nice option, as it performs the same function and is quite a lot less expensive. So firstly, you'd connect your source water, would come in on this side of the system. Then it would run through a particle filter, which is just a white filter, and this physically gets dirty from the outside going in. Then that's just for dirt. Then in the middle, the standard set, and there's a few other sets which we'll run through later, runs through a granular activated carbon filter, and this is basically mainly in municipal situations. This is to remove chlorine. Then finally, at the bottom here, it runs through a carbon block, which again is carbon, again to remove chlorine. The difference is this has got a bit of a particle filter coating around it, because the carbon filters actually create a lot of dust, which can damage your membrane. So it's just to catch the worst of that dust. Now, this kind of filter set is typically got a lifespan of 6 months, but it is something you need to look at your specific water for, as it can range dramatically. It can be a month and it can be 2 years. So it really depends on your specific water, but the average is about 6 months. What you would look for is this one, if it starts to get dirty, sort of brown past halfway, it is time to replace it, definitely. And on any of the carbon filters, if you start to feel a sliminess here at the top, then that is bacteria growing on the carbon. It's time to throw them away. Or if you start to get a chlorine smell or taste coming through. So we run through those 3 filters at the bottom here. And then it goes up to the top of the system. I'm just going to move this out of the way so we can have a look. What we have here, it goes through this little valve here. It basically is, it's what we call the 4-way valve. It basically does a pressure differential measurement here. What it does is your incoming line has got a small diameter piston that can cut it off, and this is what goes into the membrane here. And then after the membrane, this little elbow here right at the end is actually a non-return valve, so your product water can't run back into the membrane. And here on this 4-way valve, we've got a large surface area membrane, and that then the larger surface area, if the pressure starts to get similar on the product side to the incoming side, actually pushes a little plunger across and closes off your incoming water, and that's what turns off your system. Now, it's a very simple mechanism, works great for most situations. They can get damaged, and especially by high lime content, you can sometimes get a situation where, or if your particle filter isn't replaced, where you actually damage the mechanism, and this is typically the part that causes your system to keep running. So this housing here is where your physical RO membrane gets placed in. It's very important. The black seal is on the cap side, so you just unscrew the cap, unscrew the pipe from the cap, unscrew the cap, take it out of this package, push it in, screw the cap back on, screw its pipe back on, and that's your RO membrane. As we said, the one side is the one with the non-return valve right at the end, which runs back through the four-way valve, and then that runs into the T33 here, which is also just a carbon filter. It helps a little bit if you have some funny tastes or smells coming through in the water, but mainly it's used to catch the preservatives from the membrane when you're replacing the membrane. This one's lifespan is 6 months to a year typically. On the one side here you get an elbow which then heads to the buffer tank. Because of these membrane filtration processes run quite slowly, you always have a physical tank which is included. The tank only has one pipe connected to it, which is in and out, as the tank physically has a membrane inside that gets compressed by the water pressure, which is full of air, and then that air pressure pushes the water back out as you draw from it, and that's connected up to this side. You'll see all the little caps on them are nice and friendly. They're labeled, so this one you can actually see it says tank, the other one says in, right at the beginning here. And then here we have to the faucet, which you just need to drill a hole for and then connect it up there, and that will be your product water. On the other side of the membrane here, this connection right here at the back is our wastewater. So this is what I explained earlier, that flushing of the membrane. The water that gets flushed goes through here. This little mechanism here is a flow restrictor. It basically lets a certain amount of flow through. The standard one is a 300 milliliter per minute, although the flow varies according to the pressure you have. If you have a high mineral content water, you would want to have a larger flow restrictor on here, or you would want to physically buy some T-pieces and a valve to be able to bypass it and have more flow running across the membrane. But this is only for extreme situations. So that is basically the standard RO unit. Just for comparison, if we look at the one with a pump, the bottom housings are basically the same, except for that after the first housing there's actually a T-split which goes to a low pressure switch, which we'll show you in a moment here. But if you look at the top, you'll see there's quite a few extra little bits and pieces here. First you've got a transformer to provide everything with 24 volt. Then you've got a 24 volt diaphragm pump. The membrane and T33 is very similar here. I'm just going to move them out of the way so we can have a look at what's going on underneath. This little switch right here at the back, which is sort of a square block, that's the low pressure switch. This is basically just to prevent the system from turning on and running while it's not supposed to. You still have the same four-way valve connection on the basic pump unit, so same as the other system. Then after the four-way valve going on the product water side, you have a high pressure switch, which basically just turns off the pump when the tank is full and the tap is closed. So instead of only relying on the four-way valve, you now have got electrical switch just to switch off the electrical components of the system. So overall, very similar, very simple system once you get to know it. As I said, when would you use this? It's either if you have got less than 3 bar pressure, or if you're in a situation where where you really don't want to have a high wastewater, then switching to the system with the built-in pump is a good option. Here we have the different faucet designs for the under-counter systems. We have our ASO1, which is our standard one, which is a 3-lever tap. It is a completely chrome. It is still a very nice design and it's very popular. This is why we use the standard. Then here we have our ASO3 design, which is a very similar design. The neck and look of it similar. It's just that this one is a single lever tap instead of a 3-lever tap. And then we get to our ASO4 designs. Now there are two options here. There's a brushed finish and a chrome finish to it. They're very, very nice taps. They're quite a bit taller than the other designs and a lot more modern looking. And it's just a 90-degree turn on the lever there. This here is a brushed finished tap. And this one here is a chrome finish tap. On the design itself, they're identical. It's just the physical finish that is used on the metal. One of the options which we really would recommend, especially if you're doing a DIY installation, is this leak detector tray. Basically what it is, it's a little tray where you actually clamp this onto the middle housing with the bolts provided, and your unit actually stands inside this tray, or the tray hangs underneath the unit. And your incoming water line, you then connect your water in and the water to the system through this little mechanism here. The water goes in and it goes out here, and it basically is a mechanism that uses these little tabs, which we do have extra ones available if you want to purchase replacement ones. And the tab physically expands when it comes in contact with water, and it triggers the lever to flip over, which then shuts off the incoming water to the system. So the idea is that if you have a leak happening, or if you have a pressure spike or something damaging the system, that this will turn off the water supply heading to the system itself. Installation is quite simple. As I said, you clamp this onto the bottom of the unit. This mechanism gets put here. It does come with little screws and a bit of double-sided tape. The double-sided tape from the manufacturer unfortunately isn't the best, so we do recommend either using something like PVC weld glue or a more heavy-duty double-sided tape to actually fasten it securely here, as the ones provided from the manufacturer isn't ideal. There's also little feet provided in the kit which just stick onto the bottom if you want this to physically stand, if you want the unit to physically stand on this in the cupboard. Alternatively, you can mount it to the wall, or it can just hang off at the bottom of the system. It does, however, make your maintenance a little bit more annoying, as you first have to unscrew the system and disconnect the feed water on here before you can actually remove the housings to do your maintenance on the system. If you don't want to go through the hassle of installing the leak detector, or if you just want something to warn you in general if something goes wrong, we have got this leak detecting alarm, which normally you just put down in the cupboard. The batteries last quite long, and if there's any leaks, you just there we go. As soon as the water connects these 3 contact points at the bottom of the system, an alarm goes off, audibly telling you that something is wrong, come have a look. Now, this is a very useful thing. Unfortunately, it doesn't really help if you're not at home, but as a easy to use and nice thing to just add on, it really is handy, because it is a very frustrating thing if you end up with wet cupboards. Water pressure can be a huge issue for these filter systems. They're rated to handle 6 bar pressure, but we very often find in some areas where people either don't have a pressure reducing valve in front of the whole house, or if it's something like an apartment building which is up quite high, you find, and you're staying on one of the lower levels, or just certain areas where you're very low compared to where your water tower or water reservoir is, you get very high pressure. Now, the standard pressure protection valve that we use is basically just cuts off the water supply at 5 bar. So if you constantly have high pressure, it's a bit of a problem, because then your system might not always get water. Now, if you're in a situation where you either want just a little bit more control, or you know you consistently have very high pressure water, we actually have a tiny pressure reducing valve, which is an adjustable unit that you can set at the top here. If you're using one of these, we really recommend either borrowing from somewhere or getting the guy doing the installation to just check the pressure it's set to with your water. Because it's adjustable, you can easily set it too low or set it to a point where it's not being very useful at all. But the nice thing with this is if you constantly have high pressure, this pressure reducing valve can actually bring that down to a level which is safe for your system to use. Here we have the standard filters like you would get in the bronze RO system. Now, what the things to look out for is this particle filter not getting dirty too quickly. The carbon filters, whether they get bacteria buildup, if that means they're becoming slimy. Now, if you find something like this, what do? If you find that these two are becoming a bit slimy, that probably means, if it's within, say, a 6-month period, and they're quite slimy, that probably means you've got quite a bit of bacteria in the water. Now, you have two options. First, reduce the replacement time, so try it for 3 months. And if you find that after 3 months they're slimy again, that does mean you have bacteria in the water. Then you have two options. The one we normally recommend is to go to a full bacteria filter set, which basically changes the granular carbon for a KDF. KDF is an additive that physically kills bacteria inside of the carbon. It also removes some heavy metals and a few other chemical components. But the main thing is it has ability to kill the bacteria growth inside the cartridge, giving it a longer life. You can either go for a set of 2 of these, but then you still don't have something preventing the bacteria from getting to your membrane. What we normally recommend is to place a ultrafiltration membrane as your last stage then. Now, this is what the silver and gold systems use. It basically is a physical barrier at less than 0.2 micron, which is small enough to physically stop any bacteria getting through to your RO membrane. Now, what this does is it means it doesn't matter if you have a little bit of the bacteria coming through here, because we're physically blocking it here to get to the membrane. If you're planning to use this system on a borehole water, we definitely recommend using this set, as most boreholes do contain a little bit of bacteria, and the RO membranes, although they do physically stop bacteria, they don't last long if you use them in that way. And then it's a lot cheaper to rather use the more expensive pre-filters than get into a situation where you have to replace an expensive RO membrane once a year. Another thing really to keep in mind is how much pipe are you actually going to use for your installation. What you need to remember is you've got a pipe running to the system from your water source. You've got a pipe running from the system to where you want to place the tank. You've got a pipe running from the system to an easy to use drain point. And if you have a little bit of extra pipe, a really nice option is to actually take your drain point out into the garden and let the wastewater rather water the plants. And then finally you need to run the pipe from the system to where the faucet will be. Now, the physical systems vary between 3 and 5 meters that come with them. So it's okay for a minimum installation, but we really recommend go measure out what you will really need and order additional pipe if you think your installation will require it. The different size storage tanks available with the RO systems. Basically, the reason why you need a storage tank is the RO itself provides you with a slow trickle of water. As the standard units with 100 GPD membrane only provides about 10 liters of water per hour. So as you can imagine, if you want to quickly fill a few bottles or fill your kettle or the few pots you want to fill for cooking, that's going to be frustrating if you're going to need to wait for the system. Hence the tank. The tank basically works, it's almost got a balloon inside, and then you push water in and the water compresses the balloon and then increases the air pressure inside. And then once the water and air pressure is equalized, and you draw water from the faucet side, then that air pressure pushes the water back out, because then you then have lower water pressure again. Now, the standard one will give you between about 5 to 9 liters of water. The higher pressure you use on the incoming system, like this is the standard one, but if you're using the system with the pump, you have a chance that you're probably going to store more water in the tank as well. The tanks all have standard air valves. You normally want them at about 0.8 to 1.1 bar, and it's normal fittings like the garage use. If you pump them too hard though, you can't compress the air and then you get no capacity in the tank. It is something you could play around with, but normally the preset value is okay. As you can see here, we've got different sizes available. The standard one is nice as it's normally easy to fit within a shelf size. Then here we have a 19 litre one as well, or 18.9 litres, 5 gallons. It is a little bit larger, just if you want that few extra litres of storage. We currently don't have the 40 litre one on a display model to use for the video, but here's a 74 litre one. Just to give you an idea of the relative sizes, the 40 litre one is about in between these two. So if you are looking to use it at an office, probably the 74 or the 40 litre is a nicer thing to have, as you'd often find around lunch times or so, and everyone would come and draw water, and then having a bigger buffer is definitely a nice option. For domestic systems, what we personally find works really well as well is all of these tanks connect to the tank side here of the T33, but if you want to increase your flow at the faucet itself, on the line between the faucet and the machine going from this side, you can actually add a second little tank as a buffer to give you a higher pressure. We actually have a kit which comes with a tank, a little bit of pipe, a valve and a T-piece to tee into this line. And I've used that on my system, and what you actually get is you end up going from filling a 500 ml water bottle in about 14 to 15 seconds, it takes it down to about 7 seconds. So that having a tank close to your tap as an extra buffer actually increases the flow rate you can get from the system quite significantly. Me personally, I feel it's a great thing just to have that water on tap much quicker, and then you can have a larger buffer in the normal tank position if you have needs for larger storage. There are other options available. You can have plenty of these tanks connected, or you can just have one standard tank with the system. In the end, it depends on what your needs are.